Now that we've spent some time looking at derivatives, I want to look at another application or an application of derivatives, and we're going to start looking at and talking about velocity. We will start by looking at what average velocity is. So if you remember from prior math courses, distance equals rate times time. Remember, velocity is a type of velocity, or I guess maybe it sounds better to say speed, or your rate is the absolute value of velocity. Velocity can have a negative because it can have direction, whether you're slowing down or speeding up. So average velocity, if I took this formula here and divided both sides by time, I would get my rate. So I'm going to say average velocity is going to be our change in distance divided by our change in time. Again, that's just coming from our distance equals rate times time formula. We can use a triangle to symbolize change. We use S for our position in space, or how far our distance is. We use T for time. So I'm going to go through a couple examples. So in this first example, we're going to talk about a ball, a billiard ball being dropped from a height of 100 feet. I'm given the position function, so once again, S is going to be for distance or position. Our position, our S, is going to be measured in feet, and our time is measured in seconds. We want to find the average velocity over this time interval. Well, if this is my time interval, T1 is 1, T2 is 2, I need to find the position that corresponds with the time of 1 and the position that corresponds with the time of 2 so I can find my change in position. So I'm going to go ahead and plug 1 into my function, and I'm going to say when t equals 1, S of t, S of 1, is negative 16 times 1 squared plus 100. Doing that, I get a value of 84. So when t is 1, position is 84. And I'm going to do the same thing with S of 2. I put a 2 in there. And I'm going to go ahead and work that out, and I get negative 16 times 2 squared plus 100. I can put that into my calculator, and I get 36. So when t is 2, my position is 36. Well, now I need to find my change in distance, or my change in position. Well, in order to find the change, I just subtract one value from the other. So maybe I do 36 minus 84. That's going to give me my change in position. And if I want to find my change in time, I'll do the same thing. I just have to make sure, since I chose 36 first, I'm going to choose 2 first. So 2 minus 1. Subtracting, that gives me negative 48 over 1. I need to add my units. Looks like S, the distance, was in feet, and the t time was in seconds, so I'm going to have feet per 1 second, or feet per second. There is going to be my average velocity. So notice what I just found. Didn't I just find the rate at which I'm changing position in space? So I found an average rate. What if I wanted to find an instantaneous rate? Well, derivatives are what give me my instantaneous rates. So since really all I just found here was a rate or a slope, I used a slope formula for it. If I take the derivative of my position function, that will be my velocity function. So S prime is equal to V. So the derivative of my position function is equal to my velocity function. So let's look at a couple examples. Before we do, though, sometimes you're going to be given the formula like we were in the previous example. Other times you're going to have to create your own formula. Here is my basic position function for a free-falling object. I will plug G in. I'm either going to use negative 9.8 or I'm going to use negative 32. It will depend on if my my information is in meters or in feet, if it's metric or English. V of 0, V sub 0 is going to be my initial velocity, and S sub 0 is going to be my starting position. So let's go ahead and look at this function, or this example here. So at time t equals 0, a diver jumps from a platform, and the diving board is 32 feet above water. So they're starting at 32 feet above water, so I see that's my S of 0. The initial velocity, that looks like my V of 0, is 16 feet per second. Since I'm in feet, I'm going to choose a G value of negative 32. I want to know when the diver hits the water. Well, when the diver hits the water, it's like the diver hitting the ground. So I'm going to go ahead and say that means my S of t is 0. So I'm going to go ahead and find my S of t function, and then I'll set it equal to 0. So S of t, according to my formula, is going to be 1/2 times g. I'm picking negative 32 because, again, my info's in feet. T squared I don't want to plug t in because it's asking me when they hit the water, so that's what I'm going to be solving for. Initial velocity of 16, so plus 16t. Initial height of 32. So my s of t equals negative 16t squared plus 16t plus 32. So I'm going to go ahead and set that equal to 0. So doing that, I get 0 equals, and I'm going to factor a negative 16 out at the same time, and hopefully I'll be able to then factor this further. T squared minus t minus 2, which is negative 16 times t minus 2, t plus 1. I see from here I get a result of 2 and negative 1. Negative 1 does not make sense, so I'm just going to choose 2 seconds. And then part B, it asks me to find the velocity at impact. So when t equals 2, I need to find my velocity. So I'm going to start by finding my velocity formula. So I know that velocity is equal to the first derivative of my position function. I have my position function right here. Differentiating that, I get negative 32t plus 16. Well, now that I have a formula for velocity, I can find my instantaneous velocity when t is 2, since that's the time of impact, by plugging 2 into my velocity formula. Doing so gives me a velocity of negative 48 feet per second. So in other words, I am essentially moving down at a rate of 48 feet per second, which should make sense since I'm diving down towards the water. Let's look at one more example. This would be a good one to try if you wanted to give one a shot on your own. Okay, so now that you've had a chance to try it, let's take a look at it. So I look at my information I'm given. They're being dropped from a building that's 350 feet, so that sounds like my initial position. It has an initial velocity of negative 20. It's all in feet, so I'm going to choose my g to be negative 32. And I want to find the average velocity first and then my instantaneous velocity. So I know that first I have to come up with my position function. So s of t equals 1/2 times g t squared plus my initial velocity, so plus a negative 20t plus my original position. So cleaning that up a little bit, I get s of t equals negative 16t squared minus 20t plus 350. So doing the first part, if I want to find my average velocity, a lot of times written v/av, I'm going to need to know what my position is at 1 and what my position is at 2. So position when t equals 1, I'm going to plug 1 into my function here. When I plug 1 in, I put it into my calculator and I get 314. And I'm going to plug 2 in. Again, I'm going to plug 2 into my position function. I'm going to use my calculator. I get 246. So now my average velocity is going to be essentially S2 minus S1 over T2 minus T1. So again, just using that slope formula. That gives me negative 68 feet per second. In order to do the second part where it asks me to find my instantaneous velocity, I'm going to need my velocity formula. Well, velocity formula is equal to the first derivative of my position function. So differentiating this function right here, I'm going to get negative 32t minus 20. So what is my velocity after 3 seconds? What is v of 3? Well, negative 32 times 3 minus 20 gives me negative 116 feet per second. So average velocity, we're just using slope formula. Make sure you have a time 1, a time 2, a position 1, a position 2. Oftentimes you're going to need to find your position function first, and then to find instantaneous velocity, just go ahead, differentiate that position function, and then use that derivative that will be your velocity function.